Hello, and once again, thank you for joining us through our continued educational journey through surface preparation. My name is Kevin Hawthorne, and I'll be joined by industry patriarch and corporate president of Substrate Technology and Impacts Americas, Josh Jones. We'll also be joined today with Nick Gawlik, sales manager of the Contractor division for Ruwac USA, a leading manufacturer of dust collection technology. Given the importance of job site safety, today's episode will concentrate on the fundamentals of concrete dust collection. We'll specifically dive into the critical elements associated with dust collection equipment and what features a contractor should look for when considering the purchase of a new dust collector. As always, we hope you find this discussion not only informative, but beneficial to your business. Okay, so again, we're here with Nick Gawlik with Ruwac to give us his insight into dust collection. We'll jump right into the conversation. Nick, kind of explain to us the differences between a dust collector and a vacuum.
I would say the general answer to that or differentiation is dust collection is usually known as very high CFM, low lift or static pressure. A vacuum is going to be the opposite, where it's going to be typically lower CFM, but really high lift or pressure behind it. How that applies to us in the surface preparation industry, they're both important numbers. Where do we see it applied is usually the difference between a dust collection system is going to be used with shop blasters as opposed to vacuum systems are going to be more common for grinding, scarifying, sawing type applications. They're both important numbers. To have a good balance between lift and CFM is it's important to look at. Again, if we're looking at a Ruwac vacuum system paired up with a prep master grinder, for example, depending on the platform size, we want to determine what we think is going to be the appropriate amount of CFM and appropriate amount of lift. We want to think about lift being what's getting that product off of the floor itself, and the CFM is what's helping move it or convey that material through the hose.
So you said a few terms there, but let's back up a little bit. Can you explain CFM and define that in industry standards?
CFM is cubic feet per minute, which is just the amount of airflow through the vacuum system itself.
So that's the suction of the vacuum itself, the flow of air being sucked, the dust being brought back.
That is correct.
Okay, what about water lift?
Lift is just another measurement. Again, differentiating the differences between dust collection and a vacuum system. It equates to the suction or how hard you're pulling that material off of the ground itself. So again, you're using that lift to pull the material off the ground, and then the CFM is what's going to carry that through the hose. Okay.
In the last year or so, there's been a lot of discussion with dust collection in reference to job site safety. Can you go into a few, not going into OSHA standards, but just touch on job site safety, the importance of proper and maintaining good dust collection on any surface prep job site?
Yeah, I mean, people tend to forget that the most important thing behind vacuum systems, dust collection systems, is to minimize the amount of exposure to dust or harmful dust to the operators themselves. So making sure that you're applying the proper sized equipment to the specific application, to the specific point of source equipment is going to be really important to minimize the exposure to the operators and to the other tradespeople that might be in that work area. So again, sizing the vacuum properly, depending on what the equipment is, walk behind grinders, shop blasters, hand grinders, things along those lines. But managing job site cleanliness is really the most important thing for overall safety. A lot of times people want to blame the equipment or the vacuum system for why there might be airborne dust or debris and exposure, but a lot of times it can have more to do with the amount of dust and debris that's left on the floor and is being knocked up when people are brooming the floor or when they're walking through the job site. A lot of times that is going to kick that dust up in the air. So utilizing some common sense and making sure that you're using a vacuum system is going to help in that application.
Josh, if you could expand on that, you've been on enough job sites to have experienced good dust collection and bad dust collection. Can you just kind of touch on, the importance from not only operator safety, but maybe from an aesthetic standpoint, a mechanical standpoint on what dust does to certain machines, the importance of having proper dust collection on a job site?
Well, I think as Nick said, the safety concerns are probably number one. The concrete dust is an irritant. Speaking from experience, I haven't done it as a contractor. I mean, it was a much more difficult job when we came home full of dust, our clothes, up our noses, in our hair, in everything. And, thankfully the industry has truly matured in terms of the shrouding, the different types of vacuum systems, and also, you alluded to it, OSHA, getting the feds involved to have some kind of a say over job site safety, because it is a hazardous material. All I can really say about, the dust that's created during the work, if there's emissions, if there's dust in the air, that indicates there's a problem. Like Nick said, as people walk across the floor, if there's piles of dust everywhere, it's a safety concern, because it's always going to end up going in the air, because it's as fine as talcum powder at that point after it's been ground. As far as the equipment goes, it's abrasive. So over time, it's going to wear components that aren't normally supposed to be exposed to abrasive crystalline dust. Never mind the fact that the operators are breathing it, or they have to wear masks, obviously, to protect themselves. But it's going to contribute to the wear of the tools. It's going to contribute to any moving part, because it is an abrasive type material. I think, for me, I don't usually make too many complaints when I'm on a job site when I see things like that. But, to be on a job site and have visible emissions of dust, it indicates that something's not right. Unfortunately, the industry, I don't know, sees it all the time that way, and kind of thinks concrete dust really comes with the program. It's always going to be there if I'm doing any kind of work with concrete. I was just in a residential basement last week, and they said, I thought there'd be a lot more dust. I said, there shouldn't be. There shouldn't be any dust on anything. And if there is, like I said, that indicates that the equipment's not capturing that dust. So I hate to be so sterile about it. But as a manufacturer, we'd like to believe that, the equipment is going to be used safely. So job sites are safe. And also, again, it's not annoying to the labor.
So it sounds like that mechanically dust can be controlled. It's just finding that right combination of the dust collector itself with the machine or that you're using on that job site.
Yeah, absolutely. If I don't know any better, if I have the equipment that I believe is going to work together, whether it's a hand grinder, a grinder, a shop blaster, whatever it might be, if I have this equipment and I've got a vacuum system, let's say that I already own, again, the only way I would know that it does or doesn't work is if there's dust in the air. That's probably the easiest way to say that, or the easiest way to identify that something is working. If it's not, that's when I would lean on Nick. I would lean on someone like Nick to say, if I have dust from this machine, I don't know, Nick, you might be able to, you guys may have a regular formula, but if I've got the hand grinders, I got the grinders, the shop blasters. I mean, do you regularly get calls from people saying, I'm supposed to have a dustless system here and I don't? I mean, how do you guys identify if a contractor truly doesn't know why they're having this problem?
Yeah, we do. I think we probably field that phone call almost every day. And, we have a lot of contractors, Josh, to your point, where they might already own a vacuum system that they previously purchased for, let's say, a smaller piece of equipment, and they're trying to use it with the recent purchase of a larger platform piece of equipment. Well, that's kind of a red flag right there. It's probably safe to say that some vacuum is better than no vacuum, but everything has to be sized in particular. There's a lot of questions that go into play. What is the overall platform? What type of equipment is it? What is the overall platform size? Do we have 2-inch ports, 3-inch ports, 4-inch ports? There's so many variables that go into factoring what the proper size vacuum is. Hose length is something else we need to talk about. What tooling are you working with? Are we grinding? Is it polishing? Is it removal? There's so many things that we need to talk about and so many questions that we need to ask in order to try and size that vacuum properly.
So it sounds like partnering the right dust collector with the right machine is critical to not only job site safety and liability, but to the mechanical success of the machine itself. Is that fair to say?
Yeah, we talk all the time. I think we tend to default more to the side of this is why this vacuum is best for you in the way, and Josh kind of hinted on it with the overall maintenance of the machine, longer diamond tooling life. What we forget about, we never like to continually remind or scare people. We're not trying to do that, but the main purpose of these systems is for the overall safety of the operators and the tradespeople to make sure that we are containing this dust and it isn't getting in the air.
Okay, fair enough. Being a novice and going to trade shows like the World of Concrete, you're inundated with all the various dust collection manufacturers that there are out there right now. If you could touch a little bit on the key features any contractor should be looking for or aware of when they're shopping for a dust collector.
Great question. So we know in this construction industry how rough people can be on this equipment. So making sure you're buying a very heavy duty, resilient piece of equipment is going to be important. So at Ruwac, we look at a couple of things that we continue to go to over and over again, which number one is going to be the housing design or the housing material. Filtration is going to be extremely important. Maintenance is going to be important. So just like grinding equipment or shop plastic equipment, whatever it might be, you want to buy the best, most resilient piece of equipment that you can get for your dollar to ensure a low cost of ownership and constantly staying productive and profitable.
Let's take those kind of one by one. You talked about filtration and the importance of filtration. One of the words I've heard in my research is micron. Kind of explain the importance of that, what it means, what a contractor should ask when he's talking to a salesman, and what's acceptable in the industry and what's kind of superior in the industry when it comes to microns.
Yeah, so I can't speak for what the norm is for micron size and efficiency. So kind of touching on OSHA real quick, when the new silica rule came out in 2016, one of the big things is talking about filter efficiency. Not so much micron size, but filter efficiency. So for us, when you want to talk about micron, the smaller the number, the smaller the particulate's going to be. So with our filters, for instance, we're 99% efficient at 0.5 micron with our primary filter. So we're filtering out extremely fine dust with that primary filter. And to put it in some type of context, when you think about secondary HEPA filtration, you're 99.97 or 99.997 efficiency at 0.3 micron. So our primary filter is already really close to what a HEPA filter is going to do. So we're filtering out really fine dust. That's just us. In general, as a contractor, you want to talk to that salesperson, that representative about filter efficiency, how fine of a micron you're able to filter out, and then the construction of the filter, how much usable surface area you have, how much square footage of filter surface area, the material that the filters are made of. All of those things are going to dictate how efficient that filter is, how long the filter life is going to be, how efficient your vacuum will run for a longer period of time on the job site.
Talk about filter life a little bit. What should be the life expectancy of a filter? How often should a contractor expect to change the filter in a vac?
That's gonna vary per manufacturer. I think if you ask each manufacturer, you're probably going to get a pretty big difference from one to another. Us in particular, we have a 3-year filter guarantee. In this specific industry, in the way of concrete surface preparation, we're guaranteeing 3 years. We see closer to 5 or 6 years before people start to consider replacing their primary filter. However, if you look at some other manufacturers' manuals, they might tell you that you might need to replace that filter once every 6 months, once a quarter, once a month. It just depends on the manufacturer and what type of filtration they're using, what type of cleaning mechanisms they're using that are going to dictate that filter life.
Josh, any contractor perspective on that? How often do you feel in the field that filters should be changed? Now, how often are they in reality actually changed?
Well, I can only speak from, I just yesterday just did a demonstration, and that was a question: how long does a filter last? I said, it's going to depend. It is a dry filter. I said, if you change it every year, you're probably fine. I said, if it's blowing dust, you have a problem. I said, a lot of people will call when it's blowing dust. So to answer your question, I mean, I know what the manufacturer says, and that's what I would tell people as well. But I can say as a contractor, and Gawlik, you can probably back me up on this. The manufacturer says what should be done. And as the jobs go, we lose track. Periodic maintenance doesn't take place the way it should. And people randomly will find themselves with equipment that doesn't function properly. Unfortunately, the equipment sometimes gets a bad rap for that. But I don't think it can be stressed enough by a salesperson to a contractor that the filter, that's what does the work, the lion's share of the work of keeping the air clean. So I hate to cast aspersions on the industry, but I will say that when it comes to maintenance, as contractors ourselves years ago, we weren't very good about keeping a checklist of the last time the filters were changed. So I would always recommend to follow the manufacturer.
Let's touch on housing a little bit. You talked about that, Nick. Does that actually play a role in the functionality of the vac itself?
It will in a couple of different ways. The material of it, some are plastic, some might be fiberglass or made out of some type of metal or stainless steel, and they all work just fine. But if you want to think of something like a plastic or like a steel vacuum or a metal vacuum, throughout transportation or use on the job site, again, we know that contractors can be rough on this equipment and it might not be strapped properly or transported properly. Those types of things can get damaged, smashed. There's a few different things that can happen, causing a break in a vacuum seal or some hardware falling out, and that's going to affect the overall performance. Some of them might begin to rust or corrode. Plastic ones might crack more easily. With Ruwac, for example, we use a compressed fiberglass material. So our housings are what we call a bulletproof housing, meaning they're extremely durable and very difficult to break. And with that, we minimize a lot of chances for there to be some type of gasket or seal failure.
I've heard the term slows down the speed of the dust. Does the design have anything to do with the speed of the dust or the collection speed of the dust?
It can. You'll notice with our vacuums that they're an oval design when typically most vacuums are going to be round in design. And that's done with purpose for us. And the reason for that oval design is when that dust is coming into the housing, by going around that oval as opposed to a circle or round design, it's slowing down the speed of the dust. What that does for us is the filters not being impacted nearly as much or nearly as hard as some other style vacuums, which is going to help with the overall filter efficiency under operation. And then it's going to help with the overall longevity with the life of the filter also.
Okay. Moving on to pulsating vacs. I've heard everything in the gamut from they're good, they're bad, they'll corrode, the dust shorts them out. Touch a little bit about the pros and the cons, advantages, disadvantages of a pulsating vac versus a non-pulsating vac.
Yeah, it's an interesting technology. With our system, we don't see that as required for our vacuums, and that's based mainly off of our filtration design. I think when you look at a lot of these pulsing systems that are out there, a lot of it's going to have something to do with the style of filter that's being used, and they have no other way to clean those filters. We have an external cleaning mechanism that allows us to clean our filters and do everything from outside, minimizing any of that exposure. But again, with these self-cleaning pulsing systems, yeah, there's more moving parts. You might have a compressed air tank and you've got some electrical boards. These are all things that can be affected by airborne or ambient dust, which can create some production issues. And again, kind of touching on the filters themselves, some cartridge style filters, some sock style filters, our pleated filters, they all have some different type, or they all have a different way they're going to be they're going to be cleaned. And those cartridge filters in particular, seems like the only way you can clean those is by using some type of air that you're going to blow through those to pulse them out. Me looking at it from a very simple way, you're pulsing a filter out, you're knocking that dust, it's going to get immediately sucked right back into the filter. So you are giving that filter some relief in cleaning it for a very short fraction of the time. And the other thing that pulsing will tend to do is going to shorten the overall lifespan of that filter itself.
Okay. Let's talk a little bit. Josh, I'd like your input on this probably first, wet versus dry. Since STI makes machines that can do wet and dry, what are the pros and cons of doing it wet with a wet with a vac or dry with a dry vac? Is there one vac that can do both? What are the mechanical differences that someone should look out for based on whether they want to do a wet application or a dry application?
Well, I mean, speaking from the standpoint of the floor and what it needs, the only reason that I would prefer to do wet grinding or wet polishing would be if the substrate requires it. So concrete polishing in certain points of the process, marble polishing, terrazzo polishing, granite polishing. I mean, those are all types of processes that require water for the diamonds to do their work with that particular product or that floor. So I don't really have a preference of wet or dry. But again, if I'm going to be polishing concrete as an example, it's kind of mandated or dictated to me that I would use water because that's the best way to get the final clear result that we're used to seeing. When it's time to do dry grinding, maybe bulk removal, I think like Nick had kind of said, you know, what are you doing with these machines? When I'm taking off thin set or I'm removing epoxy or I'm removing a rain slab, the surface of a rain slab, there's vast amounts of waste that's going to be made. And the last thing I want to do is add water into the mix because it's only going to slow the process down because that's a lot of material to clean from the floor. As far as the vacuum types, and I'm not a specialist when it comes to the wet vac or dry vac systems, but again, I would want to make sure that I have a machine that's picking up wet waste that is water, and it also will contain that crystalline silica, which we know is abrasive. So I want to make sure that the vacuum is made to pick up that kind of waste. And as we've been talking about dry recovery, you know, it just has to make sure that we have to make sure that there's enough CFM and lift in that vacuum to be able to keep up with the dust that machine is making. So I don't know if that answers the question, but I kind of look at it from the standpoint of the application, you know, and it determining if I'm going to do it wet or dry. It's not really a preference in my opinion.
And Nick, more for you, when we are grinding wet, you're creating slurry. So what would be the difference between a dry vac and a wet or a slurry vac? And again, pros and cons, if there are any, of one over the other.
Yeah, we don't see any pros and cons. There are obvious pros and cons to Josh's point of why you would use one system or another. For us as a manufacturer, it doesn't matter. We have your dry options and we have your wet options, depending on what your preferences are or what the application dictates. Every manufacturer, again, is going to be different. We do not offer a wet dry vacuum in particular. We keep ours separate. We have dry only and we have wet only systems. If you get into some of these wet dry vacuums, I don't have a lot of experience with them, to be honest. But if you want to use it as wet, you have to remove the filter. Then when you want to use it as dry, you have to put the filter back in. And we all know that sometimes it's easier said than done to not lose the filter, not throw the filter in the garbage, have the filter installed while people are picking up slurry. So it creates all types of issues with exposure and then additional maintenance. So we tend to want to push people in the direction of a dry specific vacuum and a wet specific vacuum. And then once you determine, you know, your wet method, just like with a dry vacuum, we need to understand your application and your equipment. It's the same thing with the wet vacuum. How is it being used? And what additional features do you need in the way of wide area cleanup options, onboard discharge pump, things along those lines?
This concludes episode 11 in a series of podcasts focusing on basic principles of concrete surface preparation. Make sure to join us for episode 12, where we will continue our discussion with concrete dust collection expert Nick Gawlik of Ruwac, USA, which reviews critical aspects contractors should be aware of before purchasing a dust collection system. For immediate access to hundreds of industry tutorials and product demonstration videos, we invite you to visit the By Manufacturers Direct YouTube channel. Simply visit the By Manufacturers Direct homepage and click watch more videos. New videos are added weekly, so don't forget to subscribe and click that bell icon to be notified when we post a new video.